Hello everyone, my name is Caitlin Kavanagh and I'm a product marketer here at Revenera. I'd like to welcome you to today's webinar, Enabling Successful Software Installs with New Digital Signing Standards. Today we'll be joined by Venkat Ramdonga, Product Management Director here at Revenera, and Dave Roche, who is Director of Product Management at DigiCert. Today they'll be walking us through the current landscape of digital signing technologies, how this is affecting the future of secure software installation, and how to leverage these emerging trends for your benefit. Before we get started though, let's go over a few housekeeping details. Firstly, today's discussion will be roughly 45 minutes long. If you have any questions or comments along the way, please add them in the Q&A tab and we will try to answer those at the end of the session as time allows. If we don't get to your questions, however, don't worry, we will follow up with you after the session. We also have a number of resources available to download on today's topic, so please check those out in the handout tab. That's all from me, so over to you, Venkat and Dave.
All right, thanks, Caitlin. Welcome everybody to today's webinar on emerging trends on digital signing and the relevance and importance to the installers and the installation space. I'm happy to have Dave join me from DigiCert today, who has tons of experience in the space of digital signing, has been a key player in how software is being distributed in the most secure way possible, right? Thanks a lot, Dave, for joining us today. I'd like to give a quick round of introduction about yourselves.
Yeah, thanks, Venkat, I owe you for that generous introduction. Yeah, so I'm with DigiCert, as Venkat said. I've been working with the company since 2011, and DigiCert's primarily certificate authority company. Provides digital certificates for TLS, for secure authentication of devices and messaging in transport, but also for signing software. So code signing certificates is something that this audience should be very familiar with, applying a digital signature to an installer, to a Java jar file, and more and more expanding across different artifact types, so Docker images and containers, but all fundamentally based on the ability to apply a digital signature for, I guess, two reasons. One is to prevent tampering, right? So when you build an installer and you're using Install Shield and you've done all your due diligence, the last thing you want to do is to allow somebody to tamper with it later. So the digital signature puts a digital, like a shrink wrap around it, so it prevents it from being tampered with. But also it's great for identity. So, as an organization, you want to make sure that your customers know that this signed and tamper-resistant software is coming from you, not from your competitor or from somebody who's unknown and they are suspicious of trust. So identity and tamper resistance is really what software signing does to add value to your software as it's coming out of products like Install Shield.
Absolutely. I think, this is where, Dave, I think, I like, one of the famous, analogies I give to, people I talk to about, when it comes to digital signing is, back in the day when people had to verify authenticity of a document, you had to literally go and, put your signature on it, assuming people cannot really forge that part, right? So that was, a good analogy that I used to tell people who were, really, coming up to the speed on, what digital signing is actually, right? So I still believe that it's a very good analogy that applies to software as well, because software is produced by a reputed vendor, and who really wants to ensure that from the time it is produced from the vendor till it's actually reached to the end user, it hasn't been tinkered with, or in proper terminology it hasn't been tampered with, so there is no malicious player coming in between, right? So so that's where I strongly think that digital signing is a key revolution back in the day when it was introduced, where people were grappling with malicious players trying to tinker with their computers, right?
Mm-hmm.
So you're right in talking about installation, because in our when I say our, when we're talking to our customers and we're talking about, building installers, that are protected from these, practices, because installers are such a key component, because that's the entry point of every software, right? So before people interact with the software, the first thing they try to interact with is, how it is actually bundled with, as an installer, right? So that is where Install Shield, tries to play a key role in ensuring that the software that is bundled has a very good integration, okay, with any kind of digital signature that is being, used by the software, by the organization, and it tries to embed, the signature onto these. It's like a literal stamp of, signature saying, hey, this is verified, by a trusted authority, that this is coming in from, Revenera, this is coming in from DigiCert, this is actually coming in from Flexera, right? So, that is where, we, take pride in the way we support, digital signing technologies, and, how we help our customers with ensuring that, software is not tampered with. So, while this might sound, I'm gonna, ask you a couple of things here, David. While this might sound like a, good layman analogy, if you call, right? Can you try us, give our audience a bit about, what could be a technical definition, or what could actually mean when we're saying, we're digital signing a software or a binary, right?
Yeah. So often a little bit too much emphasis is placed on the certificate itself, because it's seen as kind of a commodity aspect to that portion of the supply chain as the software pushes through it. But really, if you think about it from a fundamental perspective, it boils down to a cryptographic key pair, right? So in a key pair, you have a private key and a public key. Okay, if I want to send a secure message to you, Venkat, what I do is I give you my public key. I sign that message with my private key, and you're able to then verify that with the public key. And the public key is like it sounds. It's a key that you give to everybody, right? So you're able to say, hey, this is what you use to verify what I've done. So the private key, though, on the other hand, you have to protect it really well, right? So, and we'll talk about how the regulations have moved in that direction, because that's a really important thing, and how security has improved in that aspect. But fundamentally, it's that handshake between something that has been signature generated using the private key and verified with the public key. Now, how do we do that ubiquitously, right? So how do we ensure that you don't have to physically give everybody the public key? So that's where the CA Browser Forum come into it. They've agreed which routes from which certificate authorities and providers are ubiquitously trusted on Windows and Linux and Mac OSs. And therefore, in terms of certificates, the public key of the key pair is in there, but it chains up to an intermediate cert and then to a root certificate that is on all these devices where your installers are getting installed. And therefore, at the time of installation, the signature can check the public key assigned with the certificate where the signature is embedded in the installer. And then it goes and checks up the chain to make sure that the root is valid, the intermediate, and then the identity cert itself has not been revoked. And when all that's done, it's also then able to say, well, has anything tampered, and has the software been tampered with? And both of those come up with then a nice friendly message to the user that says, this installer is in good shape. It's from vendor Acme Limited, and it's in good standing because the cert is valid and the root is null. So it gives that friendly, embedded, ubiquitous message to a consumer installing an installer that says, this is good. And here's who it comes from, and you should trust it. So really interesting and long-standing technology underpinning all of this, but really a kind of a very user-friendly type installation complement for good software.
Absolutely, yeah. And here's an interesting thing, Dave. We recently ran into, we being ourselves, we recently ran into a situation where a very old binary, okay, back in the day when we were not so well versed with technology itself. I think it is still out there, was not actually time stamped when we signed it, right? So.
Right.
and we discovered it the hard way, the importance of time stamping. So for our audience who are trying to implement and adopt the new practices, which will come in the next few minutes, but can you explain the importance of time stamping during the process of digital signing?
Oh yeah, 100%. So when it comes to publicly trusted certificates, there's a limit on the validity of the cert, and that is just a little over 3 years. But as everybody on this call, I'm sure, is required to, the software that you're building may need to live longer than that, right? Especially if you're building it for devices that are in the field. You think about TVs on your wall and cars that are driving on the roads. You do not replace those usually every 3 years. Even, I try to, but my wife stops me. But so what does timestamping do? Timestamping allows you to extend the trust beyond the validity of the certificate, right? So a timestamp service will enable you to extend the trust to 11 and a half years on average, somewhere between 11 and 12 years, depending on the frequency of the timestamping service refresh. And therefore, these 3-year certs don't mean it's just going to be trusted for 3 years. It means it's going to be trusted for over a decade. And that's critical, because actually what it means then is you don't need to buy 3-year certs or 2-year certs. You can use 1-year certs. And in theory, you can actually use 1-day certs, because the trust is anchored not just on when you sign, but also whether or not the timestamp is in place and that cert has been revoked. And you can revoke a cert after it expires. So timestamping is really a critical component of that ecosystem. And as you say, it's a best practice. It shouldn't harm you to do it, but it might come back to bite you if you don't.
Absolutely. I think, as I said, we kind of discovered it the hard way, and I had to educate the entire set of teams to say why it is important in setting up that practice. And very slowly evolving from the conventional PFX files, if you may, right, which were the easiest mode of actually getting access to digital signatures. And while they had their own advantages, I think this is my segue into the next topic which I wanted to converse with you today, Davis. Digital signing was way too easy. All you had to do is reach out to somebody, pay money, produce a PO, okay, and then get a digital certificate. Of course, there's a lot of legal documentation involved, but then setting up in a build pipeline, setting up in a development DevOps processes or a dev pipeline, it was so trivial, right? So. However, starting last year, okay, we've seen some drastic changes in the changes in which certificates are offered to software vendors, okay, who are producing software, right?
Yeah.
So I know that there is a specific cutoff. I think June of 2023 when certain changes came into play. But can you give us a chronology of events? I know there is a consortium of sorts that was formed. So can you give us chronology of events that has transpired into landing where we are, okay, from how simple it was back in the day?
Yeah, absolutely. So like you said, when the certificates were being regulated first, it wasn't foreseen as being a huge risk regarding how you protected the key pair, the private key that you use for signing. And what happened is that because of the value code signing could deliver, acquiring a legitimate private key and PFX with the cert included of an organization by a bad actor had huge monetary value to them, right? They could sell these on the dark web. And the reason is because malware authors could write installers, sign them, and imagine they stole a Revenera PFX, right? Mm-hmm. They sign it with your org name, with certs that are valid, and they issue it out there. And because what the practice was, like you said, was to take a copy of the key and the cert in a PFX and put it on a build server. And actually what organizations were doing was they were putting that same one on multiple build servers because you had multiple product lines going through it. And that's also a problem because you don't know what build server is signing what and when, because it all happens locally. So the CAB forum, which is the CA stands for Certificate Authorities and B is for the browsers. That forum regulates code signing, and the big players in that are Microsoft, Firefox, Mozilla, Google from a Chrome perspective, and then all the certificate authorities like DigiCert, Sectico, Entrust, and a few others. They all get together and we agree what's best practice for this. And the change that was made in June of last year was you're not allowed to get a certificate if you're going to generate the key outside of a protected FIPS compliant device or service. Right? Service is important too because the devices can be USB tokens, the little things that you like a pen drive with a FIPS compliant version of that. You can buy HSMs that you can rack in your data center, and they can cost you anywhere up to hundreds of thousands of dollars for the premium ones, or HSM services, and you can get those from cloud vendors. DigiCert, we have our own flavors of that as well. But what it means is the keys must be born on that, and they must remain there. And that's important because therefore nobody can acquire them, right? No bad actors can come in and steal them from your build servers, from your developers' PCs, from some VM somewhere where they're just sitting there unprotected. And the consequences of those cases was that GitHub themselves had an issue where they had a PFX on a build server. They were signing their own software, and it was encrypted at rest, but it wasn't in a FIPS compliant service. And it was found in plain text. The bad actors got their hands on it. GitHub decided they weren't going to wait and see if whether a brute force attack would practice or not, and they revoked the cert. And what happened? GitHub had to go and get all the Scrum teams to rebuild new versions of software, sign it with a new certificate, and push it out to customers. Now, some of those are over-the-air updates, which you can do to the cloud and services and things like that. But they also had to do some manual marketing, email-generated approaches to send emails to tens of thousands of users saying, you're on version 1.5 of this software. That's no longer trusted. You have to come and download version 1.6. You had to come to GitHub repository, pull it down and do it. So hugely interruptive to their business, right? Imagine, and Venkat, you work with product teams and engineering teams too. Imagine telling your Scrum teams to stop working on the features that you're building for your customers and go do tech debt, right? It's just a terrible conversation to have. So the CAB forum are there to kind of guide and make sure that customers are doing things well and safely and to protect them. And I think sometimes these decisions may be unpopular, but I think also you see in time customers see the value of it and realize that while PFXs on a build server was convenient, it wasn't safe.
Thanks, Dave. I think I'll just add, a couple of things there, or give a few questions back to you, right? I think one thing which I would like to tell our users is also that do not wait for your certificate renewal to get away from PFX files. And if you have already, I think please use this opportunity. There are numerous examples of certificate abuse, if you may call it, where people had really large monetary losses, right? So I would everybody who I speak to from Install Shield, we keep telling them that, hey, we discourage you as much as we say that we have the functionality to use it. In fact, we also have functionality which we can import the certificate into the certificate store and then use it like for eternity, right? Though we have that functionality, for customers, we strongly encourage our customers to get away from this and then start using the recent changes and a higher encryption technology for the protection of their organization, right? So So here is where, let me, without breaking your momentum, I just wanted to also, ask you a little more in detail about, EV sign certificates, right?
Mhm.
What are the kind of, certificate we generally have, okay? And we keep hearing and, HSM, EV, certificate based and whatnot, right? So can you shed some light on, EV based signing and, HSM? What's the key differences between them? And, you know, how does someone actually make a decision into saying, hey, I want this kind of a certificate, I want this kind of a certificate? So,
Yeah.
on what conditions, on what situations should people opt for these?
Yeah. So there's two types of public certificate for code signing. Um, there's the basic version, which was the initial version, and then there's extended validation, which aligns with the language on the TLS side, on the transport layer side. Stands for extended validation. So what it means is, from a CA perspective, from a DigiCert perspective, as an organization that makes sure that we only give these certs to the right organizations, for EV validated requests, we do more stringent checks on the company, right? And that will mean involving, humans talking to humans on the phone, not all based on automation and things like that. And verifying that everything is in place before we permit the issuance of the cert to the organization requesting it. And that's very important because, again, you can be assured then that when a company like DigiCert is doing that we're doing it to protect the reputation of all customers, including those that may not even request services from us, because we still diligently process every order from that regard. There's a couple of advantages to EV, which are different to standard code signing. So Microsoft Smart Screen Filter, when you're doing a check on the software, gives a higher degree of trust to an extended validation signed installer than it would to a standard signed one. And also, EV code signing is a requirement in Microsoft's ecosystem for driver signing. So it might not be directly related to the installer community, but for drivers, and obviously drivers can be inside installers. A lot of those have to be EV signed before Microsoft will consider verifying them for use. So EV still has an important role to play, and there's a small increase in cost because of the additional validation requirements, but at DigiCert, at least, we believe it's worth the value.
Okay. Thanks, for that, Dave. I think, when we included the, EV sign, I keep going back to this point, for our audience also, because, the conventional, PFX, signing is so simple, okay, but then, some of the newer technologies, okay, they, require a little bit of work in setting up the infrastructure, for people to get their binaries signed. But I keep saying, I think it's totally worth it. Okay, yes, it was a little painful for us to implement those in Install Shield, but it's totally worth, because customers love the seamless integration with Install Shield. Now, here's one quick thing I wanted to touch base with you, right? I mean, I think you briefly talked about it, so let me ask you, a little more in detail. I think you talked about a short-term certificates, right? So certificates I've used, or the ones we procure, are traditionally like 3-year, 2-year, or 5-year. But so in what cases do people require a short-term certificate, and is it possible to actually get a short-term certificate and an extended one for the same organization at the same time from the same provider?
The regulations around public trust certs mean that they're valid for a max of 3 years. And I think it's actually 3 years and 3 months, but a 3-year period is the max. And a lot of enterprises will say, well, and the conventional logic is, well, I'll get the longest available cert to me, because then I'll have to change it less, right? And there's some goodness in there as well regarding that. But Also, we have customers who may be in finance or healthcare or medical, and they're very security focused. They're thinking, well, actually, maybe the CAB forum is going to tell us we need to change the key strengths, right? You're going to make a regulatory change around that. And I don't want to be stuck with a 3-year cert. So I'm going to change it every year, right? We've also other customers that do a rekey every time they get a new cert, right? So they don't need to use the same key pair over and over again. And therefore it's like, well, for a security perspective, I want to change the key pair, build it afresh, get a new cert, and I'll do that every year. If you're doing that well and you have a solution or a set of workflows whereby you're able to manage the life cycle of the keys and the certs, then shorter validity certs is something that makes sense, right? Because in the same way as you don't want one certificate and one key to sign a range of software all coming from your company, you also don't want to be using the same key for a long period of time, because sometimes things go wrong, human error, right? Or you pull in an open source library and you didn't scan it properly and it gets into your software and you might need to take remediation action. So if you had a more ephemeral type of experience, and it doesn't have to be one-to-one, but it could be a shorter period of signatures where they're related to each other, but they're not cross-pollinating or risk across the rest of the business, and that's a good thing, right? Because you're reducing the footprint of what you're signing, and then you're reducing the risk of it overlapping with other products and later releases. So I would love to see our industry get to a stage where it's like every installer is signed with a new key and a new cert, used once. And if something was wrong with that, you just revoke it and it only impacts that one installer, right? That could happen because you have 5 versions out there and it's 3 versions back you need to revoke, but you don't want to impact the latest 2 or the ones before. If you sign all those with the one cert and you have to revoke, then you're going to impact multiple, maybe not all, but multiple. If you do it ephemerally, then it's a one-to-one relationship. The TLS certs have been going to shorter validity, and there's talk of them going more. At the moment, I think CAB Forum is also investigating about reducing the validity period of code signing certs and AV code signing certs too. So I think it's coming. I think that's the way the winds are blowing. But if you're in control of the life cycle of those keys and certs, it shouldn't be a concern. Actually, you should welcome it because there's security benefits to taking that approach.
Yeah, that makes total sense. The short-term certificates was a revelation to me until we talked. To me, certificates were always for 3 years, right? So
I'll convince you.
Right. So let's quickly talk about public and private. I personally do not know what is a private one, but can you help us understand what is a public trust mean and what does a private trust actually mean here? And again, is this a choice software vendors should actually make when picking up a certificate, and what cases should they pick these?
So public trust is where you, as a vendor of software, you have consumers of that software that are using a public ecosystem. So they're online, they're internet enabled, they're on Windows, Linux, Mac, and you want a ubiquitous experience when they install your software, right? So it's an open ecosystem, and in that case, using public trust code signing certs, where the roots of those are ubiquitously distributed and built into the validation workflows, that works extremely well. Where private trust works really well is where you've got a closed ecosystem or a partner or consortium type ecosystem, or maybe you want to do signing for internal use, right? So within your own company, right? So you're signing things to say, well, employees of my company should use it, but I don't want anyone outside of the company being able to use that, right? So being able to verify that, and the way you do that is you do it with a private code signing hierarchy. So instead of the root being a DigiCert root, In your case, it would be a Revenera route, right? And therefore, you decide where you distribute it. So maybe you're working with a partner, you give it to them, and they put it in the route floor. And then when you give them software, it would be trusted by them. If it leaked outside of that, it wouldn't be trusted. So you can control, therefore, the who it can participate and who can trust that software. Where private also has a role to play is in the fact that there's no regulations, right? So in that regard, there's a bit of a wild west. You can go back to putting your EFXs on the build servers again. I don't recommend it. But I'll tell you a story, right? So we work with an organization and they build robotic lawnmowers. You know those things that drive around the lawn instead of pushing it around like I do. Anyway, what they were really concerned about is the private keys used on those devices, again, needed to be in the fields, literally, for like a decade or two. Because customers don't buy those every couple of years. And if those keys were compromised because they weren't protected, there would be thousands or tens of thousands of lawnmowers in people's gardens that would stop working. And they would all have to be brought back for a recall. And that would have been huge expense. So they were saying that they wanted to protect those keys even more stringently than the CAB Forum recommends you protect for public trust code signing, because it was so critical to their business. And what they like to do as well is they like to do those ephemeral type of signing. And the benefit of that, again, is that for some versions of the software, it was good. And therefore they were able to have greater control, and they could do that with the private trust because they could issue those without validation, right? You can issue those certs constantly, and it was all within their own ecosystem. Now we help them and we maintain that as part of their PKI services, but it's owned by them, and they get great value and assurance from it, knowing that their robot lawnmowers will not stop working and the customers won't have to bring them all back to some repair center.
I think that's a good, I think this is a good, interesting topic for one of our sister products, where we get third-party applications and try to install within the enterprise after doing some repackaging. I got an EXE, I want to repackage into my standard format as an MSI, but then I also want to enforce some kind of a protection. Okay, when I'm trying to install within my enterprise, right? So LOB applications or internally built applications, do not have any excuse not to be signed. So I think the private trust probably makes more sense there. But I think I get your story as well, where those have to be more more stringent rules that are applied on those rather than the public ones. Yeah. Right. So when we talk about stringent rules, right, I think the security standards have been evolving every day. I would say, right, security is a huge topic, and while we can say neither you nor me or neither directly are into the security space, either install Shield or DigiCert, right? I think both of us kind of play a very adjacent role, okay, in ensuring software security, right? So can you talk about how DigiCert has adapted to the changes in the security landscape, and what kind of offerings you actually help with your customers to say, hey, this is how we ensure that software cannot be tampered with, right?
Yeah, absolutely. So like we've been discussing, we started with certificates for signing software, and that was very important, and we help customers with that. So when the rules in the CAB Forum changed around key protection, we were already offering a service whereby instead of customers allowing their developers globally all over the world to generate keys wherever they like, they generated in a solution. And the certs were associated there, and we did hash-based signing of all software in a cloud-based SaaS service. So your developers, whether you're in India or Istanbul or Ireland, you could just take the hash of the installer, send it up over an API, get it signed by a key held in some data center from DigiCert, and then it would be signed and sent back down. It actually performed as quick, if not quicker, than locally signing with the certificate in the search store from Microsoft. So it felt local. It felt like it was good performance, but the intellectual property remained local, and the keys were never in the wild. They could not be stolen. So we were helping customers with that. But then, you know, you see and you hear incidents like SolarWinds, and you know, they always come up. But it's an interesting story, so that's why we keep talking about it. And SolarWinds were signing their software. So what happened was something happened earlier in the process, right? So something got into the software, which was bad, right? It was malware that was exploitable. And then it got signed. So all the SolarWinds customers trusted it because it was signed by SolarWinds. And it passed all the checks and it got the nice messages at time of install. So our customer said to us then, well, how do you help us not to sign bad software? So that's where we started to work with providing integrations into software composition analysis to look at the source code and the open source libraries that are pulled in, doing a static binary analysis. So not just looking at the source code, but looking at what you built. Right? So you guys will build the installer. Let's explode that and make sure that nothing came in the build process that looked good in the source code, but is not compromised in the build process.
That's right.
And comparing those two things. And what that does is that gives us transparency into software, and the services that we integrate with will help then generate software bills and materials, right? If you're in healthcare or medical devices, or you're in finance now, you'll see the FDA and the PCI industry regulations driving software bills and materials as a requirement. So we help customers build those automatically as part of the flows. But tie all that together, right? Not just, you know, do all of these three things, but do them in a dumb way, do them in a smart way. So you should sign software, okay, but was it checked? It wasn't. So then we're not allowing you to sign. That's a policy that our customers can implement. Was it checked on? Yes. Did it pass? No. Something was detected in that scan. Okay, well, signing should also be blocked there. You shouldn't be allowed sign. Go back to the drawing board. Go fix it. And to be honest, you know, it's really important that the engineers of the customers we work with buy into it, and in time they do. Maybe the first time where they're going, oh God, I have to go back and fix something, it's a bit laborious. But actually, what takes more time is to release software and then to have to go back and patch it later, right? Mm-hmm. So actually, the engineers thank you for it when they're going, okay, I have an hour now to go back and fix it and re-release it in my release window. I can do that rather than coming in next week and spending hours to fix it and patch the software. And engineers, as we know, Venkat, you know too, they take great pride in their work. So they want to get good software at the door. So we help them with that. That reduces mean time to repair. But it's also important for security people, right? You touched on that. The security people who are accountable in our customers' companies, they don't have control over what engineers are doing. And engineers, you know, are so busy building cool stuff, right? Generating revenue through all the new features that are coming into products. They don't need the burden of also having to wear a security hat on top of that creative role that they do as a software engineer. So we try and take out the responsibility from the engineer by integrating it into a workflow. And if they try and do something that they shouldn't because the policy says they shouldn't, we stop them doing it. And that helps them to make sure that nothing happens from a human error perspective, and nothing happens from something like where a library might have pulled in something that they weren't aware of, right? Because these open source libraries are included in all software now, and you might pull in a library yesterday, and your SCA might say this is healthy, but then tomorrow that could be vulnerability. Some researcher finds an issue with it. Absolutely. So overnight, that's changed. And so we're trying to help the engineers, and we're trying to make the process as easy as possible, but add value to the security as well of the general approach.
Yeah, that's great, Dave. So I think I think I truly understand the importance of SCA. When you're delivering the software, because
Yeah,
composition is as equally important as we talk about get tamper-proof binary, because one is you're expecting a malicious actor to do something with your software, but on the other hand you are actually deliberately putting something in there, okay, which might actually cause harm to your company and your reputation, right? And
yeah,
the components that you keep in today, okay, quickly get outdated, because that's the nature of software, right? A newer
yeah,
version comes in, older version becomes vulnerable, and then before you realize you're actually out of date, right? And I see people grappling with you know
yeah.
tons of technical debt on outdated versions of components, and this doesn't just include third party kits, right? I mean, this also includes open source components, right? And
Yeah.
so
Oh, absolutely. Yeah.
yeah, go ahead, Dev. I think you were I think I interrupted.
No, no, and like actually, when we talk about attacks, we're seeing like watering hole attacks, where these common open source libraries, bad actors are trying to poison them to distribute their malware amongst other legitimate software. So
That's right.
you have to be on your toes.
Okay, so let's, I think we're kind of, close to our hour, so I think, let's, leave some time for questionnaire as well. But, I'd also like to understand for our audience who have joined in expressing interest in understanding DigiCert's, um, role in the entire software supply chain, and, what kind of
Yeah.
offerings we actually have in, securing software for our customers.
Yeah. So the way that DigiStart kind of state our position in terms of software security is that, you know, like a bit of an onion, at the core, we are altering trust within the software trust ecosystem. So we have people that are chairing the CA browser forum. They are writing the regulations, working with Microsoft and our colleagues there to ensure these standards are in place. So we're from that perspective, we're kind of setting the guidelines as to what is good software security. Um, we're then establishing trust. So how do you establish trust? Well, you do that through certificates, right? And that's fundamental to it, the generation of the keys and the certificates and protecting all of those. Um, that's at the essence of establishing trust within an ecosystem. Extending trust is by us providing some of our services, right? So services that take those certificates um, and help then to ensure that if you're doing an installer and it's getting distributed, that we do it through secure device over the air updates to devices that our customers are working with, also through the life cycle management of that. So the final thing is about managing that trust. So the certs expire, the key pairs need to get stronger, right? We've got new NIST approved algorithms now coming on stream, where we're moving away from RSA and ECDSA. And we needed to work to support customers who need to migrate in that direction, right? Those keys need to evolve, the certificates need to evolve, and there's nothing worse than you get to the end of your automated CI/CD process and you're trying to apply a signature and a cert has expired, right? You cannot just pause there while somebody goes and replaces it. And trust me, most of the time it doesn't take 2 minutes to go and fix that. You have to go back to somebody and get revalidated, things like that. So having an evergreen, secure CI/CD pipeline is I guess what we're all kind of striving for.
Yeah.
So DigiCert believes that we have a role to play there. We're not saying that we do it all, of course, right? We don't. That's why we're here. We're listening to Revenera and the great products from Install Shield, and it's in partnership that we can help to deliver these to shared customers.
Right. Thanks, Dave. I think that's a good insight onto what, how, and how you can help our customers get into producing software that is not just secure but also distributed in a secure way, right? So here's where I'd like to inform our customers about how we have adopted the technologies that has been evolving in digital signing. I go back to my opening statement of how digital signing was a very simple process. You have a PFX, put it on a build machine, okay, expose the password everywhere in your batch files, your script files everywhere, and then you're good to sign, right? But then, as technology kept evolving, okay, well, the first challenge we had was, EV-based signing, limited, token that keeps expiring, and people had to key in their passwords and whatnot, right? I think, what we have, we either had to choose between, supporting every, signing technology out there, okay, or, okay, what the team actually did was, we implemented, what we call as, custom signing, right? So custom signing, is something that we take, real pride in because, it's not, inclined to just, one certificate authority provider or one technology.
Yep.
Okay, but you name it, okay, and you'll be able to actually, as long as you have, a utility that leverages a particular service, okay, either it is a hosted service or it is, within the premises, okay, you will be able to, sign your binaries, right? And one of the other items, Dave, we keep hearing about is how Windows 11 itself is evolving a lot, and some of the organizations have enabled a lot of security settings on Windows 11, like the SPA tab control, which absolutely prevents any unsigned binary to not run on the machine. It's a strict no, right? So that is something we advocate our users to do it, and especially on the enterprise side, to ensure that the Windows 11 devices have this setting enabled. But then that calls for there will be an odd binary that has been built by some vendor, okay, back in 2010 or 2005, okay, which is not signed, right? How do we deal with that particular situation, right? So for that reasons, we also take pride in not just signing an installer, right? I think Install Shield does two layers of signing. If the binaries that are used by you, okay, they are .txt, .dlls, or any kind of binary enable extension, and you want to enable users to say, hey, I can support a Windows machine with smart app enabled on it. Okay, so we do a two-step process of signing the binaries within the installer first. Okay, and then signing the outer layer as well. And for those users who have dialed in today, in case you're curious to know more, I think we'll there is handouts here which talk about it. Explore the custom signing solution that is there, because it is not easy to just install Shield on a server, okay, that has a signing setup, right? IT will not allow it. Because it's a third-party software, and it's an oxymoron where you're trying to secure your system at the same time you're installing another third-party software on it, so it's not simply allowed, right? So that is where we come in and say, hey, what? As long as you're able to access the service, okay, like from a utility, okay, you're free to use that and embed that within Install Shield. So any users who are willing to explore this, please reach out to us. We're happy to walk you through the process. It's a very simple process, really, and it takes in every file by file and signs them, and then puts them in the installer and signs the entire installer, right? So this includes EV signing. This includes name anything. I think in this we should be able to support it. If we are not, okay, we're happy to work with you. And Dave is here. We're working very closely with Dave to see how we can support of some of the DigiCerts cloud services ourselves. So, but if you're using any of the DigiCerts offerings and you're not able to make it work, okay, feel free to reach out to me, Dave, and we're happy to help on those. Right?
Absolutely.
Yeah. All right. I think that's a very good talk, Dave. I think we covered a lot of topics there. Right from security standards to the evolution. I don't want to call myself old, but I've seen this entire evolution myself. I'm sure you have seen as well. But it's a good talk to help our users understand where we stand today and how things keep changing. Right? We talked about the consortium and some of the changes that are coming in with short-term certificates and everything. So Let's see if there are any questions from our audience. Okay, we'll take a couple of questions and then wrap this up today. There is one question here on Azure DevOps pipelines. Yes, we. The question. Let me read out the question here. So, do we support custom signing when building in Azure pipelines? Absolutely. I think the custom signing functionality is available both in the project, like you can embed, the custom signing functionality within the project, or you can also leverage that within the standalone build. So if you're using the Azure services for your build systems, which which have seen a shift in our users use models, where bulk of the build processes are happening in Azure DevOps pipelines. So you can leverage our extension, you can leverage the command line support over there, okay, to leverage custom signing in Azure DevOps pipelines as well.
And DigiCert also has an extension for Azure DevOps pipelines as well in our to deploy the tools when you're setting up ephemeral pipelines. So if you wanted to use two services together, you could use both of those and sign with DigiCert through the Install Shield custom signing approach. So if you're on Azure DevOps, we got you covered.
I think we should talk more about it and see how we can have a native support there. Dave.
That could be a good topic for our next time.
Absolutely. There's a question for you, Dave. I think there's a question which says, are DigiCert signing solutions FIPS compliant? Can you take this?
Yeah, absolutely. So someone was listening or is knowledgeable in this area. So FIPS compliant is 140-2 level 3 specifically is the requirement from the CAB forum for key protection on a device or a service. And what it means is that the keys are locked to that device. They're born there. They cannot be exported, so they can't be acquired by a bad actor and taken off of the device. And so, yes, our solutions are compliant with that. We actually have embedded workflows that will not permit keys that are in other devices to be used for public trust code signing issuance. So we are compliant in that regard, and therefore, by buying the solution, you're also compliant. You don't need to worry about the standards, and we'll evolve as the standards change. So if you're a customer of ours, you'll be compliant by the fact that you're using our services.
Yeah, thank you. There's a question here. I think it's I think it is for me regarding this is a question from Prem here. Saying regarding smart app control, some of the errors we get are on Microsoft DLLs and EXEs. Is this feature released worldwide? Okay, I think I'm going to anticipate the question here and make some assumptions here, Prem. Here, some of the older versions, Prem, of Install Shield were still using very old binaries of Microsoft, and as you understand, it's an unsigned binary, and Windows wouldn't simply allow it to install, right? So I'm gonna tell it out in a transparent way. When we reached out to our legal team and then said, hey, there is a Microsoft binary, can we put our timestamp on it, our digital signature on it, our team said, no, you can't do that, right? So this is the one of the topics that I and Dave were talking about as to how we should actually be up to date on the components we use. And the latest versions of Install Shield do not have any such issues, and all the binaries from Microsoft that we include are actually signed and time-stamped by Microsoft, so that you shouldn't actually face these issues. But if you're talking about an installer generated, which we do not include any third-party, binaries from Microsoft into the installer, this shouldn't be the case. So, in most likelihood, if I understood the question right, Prem, upgrading to the latest version of Install Shield should be, you should get rid of this problem. Okay. If not, you can reach out to us, via support, and we're happy to help you. All right. There's one more small question. I think we'll take that, which is custom signing available in the professional edition? Absolutely. I think digital signing is such a key need. Okay, there is a distinction between monetizing something and offering as a service, and this is one thing where we do not want our customers to stay behind. And custom signing is available in both professional and the premier editions of InstallShield. I think we've come to the end of it. I think let's hand over to Caitlin. Caitlin.
Thank you very much, Kanika and Dave, and thank you to everyone else for joining today. You should shortly see a poll pop up on your screen. So please let us know if you would like to hear from DigiCert about the topics discussed today. As I mentioned earlier, we have a number of resources available to download on today's topic, so please do check those out in the Handouts tab. But other than that, we're almost at the top of the hour, so we'll see you at the next webinar. Thanks, everyone.